Hello everyone. In this video, I will explain how to calculate strain crystallite size. So, first of all, we need to fit the peaks of XRD. So, let us select any XRD pattern. So, this is our XRD pattern. So, we need to plot WH plot. For WH plot, at least 5 peaks we have here. This peak we will not consider. So all the 5 peaks we will fit with the Gaussian, and we'll calculate FWHM and the position. So this peak is around 32. So first of all, we will change the scale to 31.5 to 33.5. So this is our first peak. We need to fit it with single peak fit, and the function would be Gaussian. Then we need to select the data range, select range from the graph from here to here. Okay, we have selected it here. Go to the Gaussian function again, then start iteration, one iteration, two iteration, like this, then till it converge. So this is the parameter. So from here we can find out the peak position, which is 32.4442, and FWHM is 0.28867. So these two readings we will note it down in our notebook. So delete this. The second peak was around 39, so I will change the range 38.5 and 40.5. So okay, so make it 41. Yeah, then this range around 800. Now same process, Gaussian, data selection, select range from the graph, this range. Okay, again go to this, start iteration, it's being fitted, then final. Okay, if you want to switch the report sheet, then yes, otherwise no need of it, no. So here you can see the position of the peak is 39.99876. This is 2 theta, and this 0.30515. This is FWHM in degree. Remember, we use this FWHM in WH plot in radian. So we need to convert it in radian. Now it is in degree. So like this, we have to fit all the peaks. So we have fitted only two peaks, this and this. So we have to fit these three peaks also for WH plot. At least 5 points we need for WH plot. So this was already 3000. So these two peaks we have fitted. So now we have noted down the position of this peak and position of this peak and FWHM of this peak and FWHM of this peak. So I have already done all the work. So we will switch to our worksheet. So this was 2 theta for all 5 peaks and beta in degree. Now we need beta cos theta and sin theta. Why these two columns we need? Because the WS plot is beta cos theta is equal to C epsilon sin theta plus K lambda upon L, or somewhere it writes D. So L or capital D is crystal size. This epsilon is strain, and this beta total is FWHM in radian. So theta, this is half of 2 theta. So we need to plot a curve, a straight line y is equal to mx plus c, uh, which is beta cos theta and sin theta. So this intercept will give us k lambda by L, and from here we can calculate crystallite size, and from the slope we can calculate strain. So let's start. uh, so beta we have in degree. So first of all we will convert it in radian, then we'll multiply with cos theta. So this is 2 theta, remember. So we need cos theta. So and again we will need sin theta, then we'll plot a curve between these two columns. It will be convenient for us if we change uh, in radian. So insert a column here. So this is theta column in radian. So the value of theta would be half of it. So we will set the column values. Column 1 divided by 2. So this is in degree now, and multiply it with 22 by 7. Put it in brackets. So and again we have to divide it with 180. So now this is in radian. These are the values in the radian. So this beta in degree. So insert a column here. Now beta in radian. So how will we convert it? Set column values. Again this column B. Yeah, this is in radian, so we need to multiply it with 22 by 7 and then divide by 180. So it was in degree, now it is in radian. Apply this. Okay, now what we need? We need beta in radian and cos theta in multiply. So we have uh, two columns here, so we will use them. Beta in radian is column f1 into cos theta. So put function mathematics cos x cos theta. Theta, where is theta? Theta in radian is E1. So column E1. So apply. Now this is the value of beta cos theta. Similarly, sin theta. So set column value sin which column is theta in radian E1 column E1. So it will give us sin theta. So we need to plot between this. So this should be x. So set it as x axis. Now this is y axis and plot them. So you will find like this. So we have to fit it, fitting linear fit. This is intercept value. From here we can calculate crystal size, and this slope, this will give us the strain value. From the formula you can see this slope will give strain, and this interception will give crystal size. So manually also we can find out, like we can calculate 2 points. One is this, note it down, the x value and y value. So this x value and y value, then dy upon dx. So this will give us the slope, and we can change this axis parameters from 0.004 to make it 2, like this. Then extrapolate this. Now check the value here. The value is 0.0039 of this intercept. So the intercept given by the origin was 0.003 till the third decimal point only. So it is always better to calculate ourselves because it is near to 0.004. Now we can use it to calculate the crystal size and the slope by dy upon dx to calculate strain. Thanks for watching. Please subscribe the channel.